Good morning, guys. Myself, Sridhar H., working as assistant professor in the Department of Electronics and Communication at Government Engineering College, Haveri. So, in this basic electronics of module 4, that is BJT applications, feedback amplifiers, and oscillators. So, in this last session of this module 4, that is 555 time. What do you mean 555 timer? The 555 timer oscillators, which are most commonly called as a 555 timer. So normally the 555 timer oscillator it is. So but normally we will be calling it as 555 timer. The basic 555 timer gets its name from the fact that there are three internally connected 5 kilo ohm resistors, which it uses to generate the two comparator reference voltage. The 555 timer IC is very cheap, popular and useful precision timing device which can act as either a simple timer to generate single pulses or long time delays as a relaxation oscillator producing a straining stabilized waveforms of varying duty cycles from 50 to 100 per pulse. So it is very much cheaper, popular and very useful precision. So it will have a duty cycles of 50 to 100 per pulse. Okay, so normally most of the time we will be using of just the naming of 555 time. Okay, so this one is the 555 IC, how it will be just looking, and this one is just the pin configuration of a 555 IC. That is a 555 is a bipolar 8 pin mini dual inline package, that is a DIP device, and it IC consists of 23 transistors and 2 diodes and 16 resistors. That will be just showing in the later. Okay, how it has been just entered. So initially what it is just the IC, how it been representing. And so this one is just the pin diagram. That is pin number 1 represents your ground, pin number 2 trigger, 3 is the output, say 4 is the reset, and 5 is the control voltage, 6 is threshold, 7 is the discharge, and 8 is the VCC. Okay, so pin number 1 is ground and 8 is the VCC. So these two are the power supplies, and the pin number 3 is the output. Okay, so ground and the pin number 3 is the output, remaining all are acting as the input. Okay, see here. So this one is the 555 timer. So this one is also a pin diagram. So how it is normally it is been used. Okay, the pin number 1 is the ground, that is it connects to the 0-volt power supply. So this one is acting as the output. Pin number 2 is what? Trigger, that it detects 1/3 of the rail voltage to make output high, and pin number 2 has control over pin number 6. So normally, so if you're just going for a stable, then pin number 2 and 6 are being just shortened. That is pin number 2 is been just having a control over pin number 6. If pin number 2 is low and pin number 6 is low, output go and stays high. So if both pin number 2 and pin number 6 are low, then the output is high, and if pin number 2 is low and pin number 6 is high, the output goes low. So it is, we are telling it as depending pin and 2 pin is having a control over the pin number 6. Next, this pin has a very high impedance about 10 megahertz and it will trigger about 1 microfarad. Pin number 3 is that is output, that is pin and 3 and 7 are in phase. Goes high, that is about 2 volt less than rail, and low about 0.5 less than 0 volts, and deliver up to 200 milliamps. Okay, so normally goes high means about 2 volts and about 0.5 less means, so it will be having a range. So anything voltage about the 2 volts will be high, and anything ranging from 0 to 0.5 will be of a low. So pin number 4 is the reset. It is a reset pin and it should be connected to the positive rail to of a network IC properly. When this pin is grounded, the IC will stop working. That is, if a reset pin is 0, then it will the IC stop working. That is, it will all set to a 0. The reset voltage required to this pin should be a 0.7 volts at a current of 0.1 micro amps. The reset pin, that is 0.7 means, so it will be having a range of 0.7 to any 1, that is 1 volt, it will be having the 1. Pin number 5, that is a control. The voltage applied to this pin will vary the timing of the RC network quite considerably, and the 2/3 supply voltage point on the terminal voltage divider is brought to the control pin, and it requires to be connected to an external DC signal to modify the timing sample. That is the control signal, and it should be connected to the external DC signal. Next, pin number 6 is the threshold. So the timing cycle of the completed when voltage on this pin is equal to or greater than 2/3 of the VCC. So this one 2/3 of the VCC. So threshold voltage is the one which will be just compared. Okay, this equal and 2/3, and it is connected to the non-inverting input of the upper comparator so that it accepts the positive going pulse to complete the timing cycle. And the typical threshold current is 0.1 milliamps, and this is case of reset pin. Okay, and the pin number 7 is the discharge pin. That is, it provides a discharge path of the timing capacitor through the collector of the NPN transistor to which it is been connected. So discharge path means what? It is also acting as a input, and the maximum allowable discharge current should be less than 50 micro, otherwise the transistor may damage, and it can be used as an open collector loop. So pin number 8 is what? The VCC, and it is a positive wire connected to which it is connected to a positive terminal of the supply. Okay. Next, the ECC works in the wide range of voltage 5 volts to 18 volt DCC, whereas the CMOS versions works with the 3 volts VCC. Okay, in the previously, so all the systems whatever you will be using of a 5 volts to 18 volts, that is normally of a 5 volts power supply, but since the want to reduce the power supply, that is the power supply storage, and to make the battery life higher, so normally people are been in the today's market will be using just for a 3 volt, that is of a CMOS battery, that is of a 3 volts. So this one is just the first slide that it has told that it will be having a 16 transistors and all those stuff. So this one is just the 555 trimer block diagram. So where you will be having two comparators, comparator 1 and comparator 2, as well as the one SR flip flop. Okay, and this one is the discharge transistors and the resistors along with the invert. So this one is just the main block diagram. Okay, just if you want, just for the reference it has been just mentioned. Normally what you will be having is the pin diagram. Okay, so this one is totally the pin descriptions. Okay, pin number 1, that is ground. So it is acting as the output, that is for the ground reference voltage. And the pin number 2 is trigger, that is it is acting as the input responsible for transition of for a SR flip flop. And pin number 3 is the output pin, that is it is acting as the output pin and output driven waveform. Okay, next the pin number 4 is reset, it is acting as the input, and the negative pulse or reset will disable or reset the timer. That is, if reset is 0, then it will be in a off state, and if reset is 1, then it is acting in a then control voltage, control the width of the output pulse by controlling the threshold and trigger levels. Next, threshold, compare the voltage applied at the terminal with a reference of 2/3. So the threshold is what we should be comparing with the 2/3 of the voltage. Discharge is also acting as the input connected to open collector of transmitter, which discharges the capacitor between intervals for charging and for discharging. Next, VCC supply. So this one is just also acting as the input, that is of a supply voltage. Next, now so we'll just go with the next. So it was the initially what you people have got just for the 555 timer. Okay, now you people have been going whether it is what are the conditions, that is astable, monostable and bistable, but for your syllabus it is having only a stable. So a 555 oscillator is another type of relaxing oscillator for generating stabilized square wave output waveforms of either a fixed of a, that is 50% to 100% fixed. Next, so this one is just the basic block diagram of a bistable 555 oscillator. So this one is the input what will be giving a normal sine wave, and you will be getting a stable output. Okay, T1 and T2. So the time for T is equal to what? T1 and T2. So we are just comparing the fun. So these are the pin number, that is 1, and pin number 1 is what? Ground, it is being grounded. Pin number 2 is been triggered to be always normally the pin number 2 and 6 will be always shorted. Pin number 7 is the discharge. Pin number 8 is what? The VCC, that is it is connected to a plus y to 15 volts. Okay, so this one is just the threshold voltage what it will offer 2/3 of the VCC and the one. So we are just comparing the voltage, that is 2/3 of the capacitor voltage and 1/3 is the point. So this is the point where it will be charging, discharging and charging, discharging and charging, and during this point how this we will be getting a stable output of a 50% or 100% of the, so 0 to 1, that is T1 and T2, and T is the capital T, that is the time cycle is what, T1 plus T2, that will be just cross checking later. Okay, so this one is just the block diagram, the pin diagram of what it is been just internally corrected. That is pin number 2 and 6 for our stable will be always shortened and are connected together, allowing the circuit to re-trigger itself on each of the every cycle, allowing it to operate of a free and running oscillator. Okay, during each cycle, capacitors C charges up through the both timing resistors R1 and R2, but discharge itself only through resistor R2. Okay, see here. While charging, it will be charging for, it will be taking both the resistors R1 and R2 help, but for discharging, it is just discharging the R2 values, and the other side of the R2 is connected to the discharge terminal, that is of a ground, that is of connected to a pin number 5. Next, the capacitor charges up to 2/3 VCC. Okay, the upper comparison limit which is determined by the 0.6393 R1 and R2 into C combination. Okay, and the discharge, so charges is of 2/3 of the VCC, and the discharge value is what, 1/3 of the VCC, that it is been just charging point, it is what, 2/3 VCC, and discharging is what, through 1/3 of the VCC. This results in an output waveform whose voltage level is approximately equal to VCC, that is 1.5 volts, and whose output is on and off time periods are determined by the capacitor and resistor combinations here. So this one is the total stable 555 timer oscillator output waveform. So charging point is what, 2/3 of the VCC, and discharging point is what, 1/3 of the VCC. Okay, charging through what, through our resistor R1 and R2, so only discharging through only the R2. Okay, so TC, and this one is the operand. So T on and T off. The transistor is that is T on means charging is on, discharging means charging is off. So total time is what, T on plus T off. So this one is just the normal VCC what will be having, that is over 1.5 volts, or normally it will be taking it as 1. So these are the capacitor voltages. Okay, so charging point and discharging. During charging it is of T on, and for discharging it is T off. Okay, so stable for discharge timing, that is the formula, that is a normal formula for T1 is what, charging point is 0.693 R1 plus R2 into C, as both the charging will be taking place for at R1 and R2, but during the discharge point it is only for part 0.693 into R2 is only considered, not the R1. So it will be having, where R is in ohm and C is in farad. When connected in an unstable mode, the output of the from the 555 oscillator will continue identify charging and discharging between 2/3 VCC and 1/3 VCC until the power supply is removed. Okay, when it is been just connected with the 555 timer, so always it will be in the range of 2/3 VCC or the 1/3 VCC, that is charging and discharging. Next, the cycle time is given with what, 555 oscillator cycle time is the formula, T is equal to what, T1 plus T2, that is T on and plus T off, that is the 0.693 R1 plus 2 R2 into C. So this formula is the formula. So for the charging formula is what, 6.693 R1 into R2 plus into C, R1 plus R2 into C. For T2 it is 0.693 into R2 into C, and the capital T for the duty cycle T is for T1 plus T2. So the formula is what, 0.693 R1 plus 2 R2 into C. So the 555 oscillator frequency equation is given by the formula, that is F is equal to 1 by 2. 1 by T, that is the formula is what, 1.44 divided by R1 plus 2 R2 into C, and the duty cycle is T on plus on and off, that is T on divided by T off plus T on, that is R1 plus R2 divided by R1 plus 2 R2 percent. Okay, so if both resistors R1 and R2 are equal in value, then the output duty cycle will be in the ratio of 2.1, that is 60% is on time and 33% is off. So if it is having R1 and R2 both, if you just take for equal value, then the on time is of 60% and off time is of 33% with respect to this period, that is 66 and 33. Next, we just take a formula here. So what it is been just representing here. See, an astable 555 oscillator is constructed using the following components, that is R1 is equal to 1 kilo ohm, R2 is equal to 2 kilo ohm, and capacitor C is equal to 10 microfarad. So calculate the output frequency from the 555 oscillator and the duty cycle of the output waveform. Okay, now solution. T1 capacitor charge on time is calculated with the formula what? T1 is equal to 0.693 into R1 plus R2 into C. Just substitute the values. What we will be getting is what? 0.021 seconds or 21 millisecond. In the same position for discharging from formula is what? The capacitor discharge of time is what? 0.693 R2 into C. So it will be having the value of 14 millisecond, and the time cycle is what? Total time is being calculated as T is equal to T1 plus T2. So if you add it 21 millisecond plus 14 millisecond, then you will be having a value of 35 milliseconds, and the frequency is given by the formula what? F is equal to 1 divided by T, that is 1 by 35, that is 28.6 hertz, and the duty cycle formula is what? R1 plus R2 divided by R1 plus 2 R2. So if you substitute the values, you will be getting F of 0.6 or 60%. Okay, so normally the T on time is of 66% and 2 off will be of 33%. So nearly you will be having of a 60% for this formula. So this completes your 555 timer as well as the module 4 oscillator, that is BJT feedback amplifier as well as the oscillators. Okay, thank you.